All right, geometers, welcome back. Here we are, another beautiful day of advanced geometry. As you recall, pre-pandemic, we were in the midst of chapter 10, which was volume. And one thing we didn't get to was the volume of a sphere. And also when we did surface area, we didn't do the surface area of a sphere either. So we're going to throw all this in right now today. And then in the next lesson, you'll see there's a little bit of application with similarity as well. So first things first, what is a sphere? You guys all know what a sphere is, I'm sure. You've seen it. A ball, basketball, baseball. The Earth is pretty darn close to being spherical. Not quite perfect, but close. All right. Even though I'm a flat earther, I'll give you that one. All right, so here we go. A sphere is the set of all points in space that are a given distance, which is called the radius, from a given point, which is called the center. So in this case, you have some center point, and every single point along the sphere in all directions, 3D around it, is the same distance, r, from the center. All right, so in the video you watched, the derivation of the volume formula for a sphere, kind of use what we learned about cones and cylinders. You found that the volume of a sphere, to find the volume of a sphere rather, we use this formula that the volume is equal to 4/3 pi r cubed. Alright, so we're going to use this formula, do a couple examples, find the volume of some spheres. Alright, here we go. So in this first example, find the volume of the sphere below. So step one, just like when we did all those multi-step problems with formulas, we start off and use our formula. The volume of a sphere is 4/3 pi r cubed. You'll notice this is really nice because the only thing we need to know is the radius. We are given the radius. We plug it in, and then we're just going to do a little bit of algebra. So 4/3 times pi times 4 cubed. Perfecto. All right. Next thing I'm going to do is, because I'm dealing with this fractional part, I'm just going to go ahead and make everything a fraction. So 4/3 times pi over 1 times 4 to the third power, you guys. 4 times 4 is 16. Times 4 again is 64. All right. So the next thing I'm going to do is, because I've got fractions here, I'm just going to multiply straight across. And when I do that, 4 times 64 times pi on top gives me 256 pi. And on bottom, I have 3. Now, if this is not divisible, then we don't want to put a decimal. We would just leave our answer as such. But when we divide this, we want to see if it's divisible. And I can tell you right now that it's not. When I divide it, I get 85.3333. So let's just leave our answer here as a fraction. And of course, it's volume, so we'll put inches cubed. So please do not be afraid of fractions. There you go. Now, in the next one, I can go ahead and tell you that I'm going to have you guys try to do this one on your own. So I want you to pause the video and do it on your own. But because this number 6 is divisible by 3, your answer at the very end will be an integer value in terms of pi rather than a fraction. So you can pause the video right now and try it on your own, and then we'll make sure you got the same thing as I did. Okay, welcome back. Hope that was a great pause there. All right, so here we go. We're going to start off by volume is equal to 4/3 times pi times radius cubed, which gives me 4/3 times pi times 6 cubed. All right, and 6 to the third power, 6 times 6 is 36, and then 36 times 6 is 216. So I get 4/3 times pi over 1 times 216 over 1. And when I multiply straight across, 216 times 4 gives me 864 times pi on top, divided by 3. And this is divisible by 3, like I said, so you should have gotten a volume of 288 pi cubic inches. There you go, friends. Volume of a sphere. All right, so let's just apply that to some other things, some composite figures and hemispheres. All right, so in this example, this time we want to find the volume of, this is a hemisphere, all right? So half of a sphere. So if you think about the volume of a sphere as being 4/3 times pi times r cubed, if I want to have half of a sphere or a hemisphere, I simply will multiply this formula by 1/2. And when I do that, when I multiply my fractions together, the 1 times 4 there gives me 4, and on bottom I would get 6. So this would give me 4/6 pi r cubed, but you can simplify that fraction to give you that the volume of a hemisphere is 2/3 pi r cubed. And that should make sense, because if an entire sphere is 4/3, well, then half of it will be 2/3. So I'm simply just going to plug in here. Again, because this radius is not divisible by 3, when I cube it, it's still not going to be divisible by 3, so I'm going to end up with a fraction here, and that's quite all right. So I'm going to plug in. I get 2/3 times pi over 1 times 10 to the 3rd power over 1. 10 to the 3rd power, you guys, as you know, hopefully, is 1,000. So I'm going to end up with 2/3 times pi over 1 times 1,000 over 1, which gives me a volume of 2,000 pi over 3, and that's cubic centimeters. All right, so when it's a hemisphere, it's best to use 2/3 pi r cubed, because you only want half of that sphere. All right, so in this case, this is where we get into like some multi-step problems. So there are 2 things we need to find the volume of here. All right, we've got the hemisphere. All right, so I'm going to do the volume of the hemisphere plus the volume of the cylinder. All right, so just like in those chapters 9 and 8 and all those multi-step chapters, I'm going to start by just, putting my plan, then my formula, and then I'll plug into it. So the formula for the volume of a hemisphere, we know, is 2/3, so this top part's the hemisphere, times pi times r cubed, plus the volume of a cylinder is the area of the base, which is pi r squared, times the height, which in this case will be 30. We'll get there. All right, now, the hemisphere. Cylinders have congruent bases. So if the radius of this base down here is 12, then the radius of this base is 12, which means the radius of this hemisphere is 12. So 2/3 times pi times 12 cubed. And also, based on the previous examples, if this radius is divisible by 3, then when I cube it, it will be divisible by 3, which is nice, which means I will not have a fractional part for this. And then for my cylinder, it's pi times the radius squared times the height of the cylinder was 30. There we go. So now we just do the math. So I'm going to do everything with fractions again to kind of show my work. This is 2/3 times pi over 1 times 12 to the 3rd power. Let me punch out in my calculator here. Is 1,728. All right, plus pi times 144 times 30. So over here I get 1,728 times 2 gives me 3,456 pi over 3 plus 144 times 30 gives me 4,320 pi. All right, so now when I divide 3,456 by 3, I end up with 1,152 pi plus 4,320 pi. And then they're both in terms of pi, so they are like terms. So I will combine those, and I'll end up with the volume of this entire composite figure, that is a cylinder and a hemisphere, looks like a silo, right, is 5,472 pi units, which in this case is feet cubed with its volume. Here you go, folks. That is volume. All right. So the next thing we're going to do is we're going to go into surface area. All right. So what I'm going to do here, though, is I'm going to stop the video and I'm going to start a new one for surface area. So it'll be part 2 of today's lesson.